My name is Nick, and I'm going to be talking about Kotlin on code quality tools. Okay, so let's go and start with the motivation, why we might actually want to go and use them. So the first example is, for instance, a class that has like many functions, and this is something that we generally try to go and avoid. But as the time and the project grows, usually you go and add more and more many things, and those tools can just help you by saying, okay, hey, this class is something that is just too big. Another example is, for instance, this class, which is just completely not formatted. So like everything is like on its own intention, everything is like on its own line, and instead it should be looking something like this. So it's like nicely aligned, and the spacing is correct, and according also to the style guides. Another example is that class. Can you spot the error? Here, the wrong variable was used. So also tools can go and help us by detecting unused variables or parameters, and forcing us to go and use them, or either to go and remove them. Another example is this one. So for instance, if we take a string and we uppercase it, uppercase and lowercasing is actually depending on the locale. So this one is using the default locale, but this is maybe not something that you want to go and use. So for instance, the Turkish language has a different I, so that's going to be different. So instead, we go and enforce by explicitly saying, okay, locale, we go and choose US. Another part is you have an interface, public interface that consumers can go and use. So we should be adding documentation to it. So there's also checks that can go and enforce that. And it can even go as far as saying, okay, the sentence should be a sentence and should also be ending with a dot. Because the documentation is important and we should treat it as high as the code itself. Another check that is also useful is for checking dependency updates. So for instance, there's the Kotlin runtime library. So it's 1.2.70, but there's actually a newer version. So those tools can also go and check that. And then also classes like this, where we have like two parameters, and they should be data classes. So what tools are there that we can go and use? The first one is Android Lint by Google developed. Second one is Detekt, which is developed by Arthur, a German guy. And then there's also Lint. And each of those tools have like different things they go and do. So if we go and start comparing them, Java is supported by Android Lint, not by Detekt and Lint. Kotlin is supported by Android Lint, Detekt, and Lint. And all of them have like a binary that you can execute. So you don't need to like go and do something specific. You just have a binary. You pass in like the files that you want to go and check and some configuration, and that's all done. Configuration is also supported by almost all of the tools. Lint has like a very minimal configuration because they are mostly complying to the style guidelines from Android and JetBrains. So there's not much need for configuration, but other tools have like very specific configuration that can go and define those rules. Static analysis is supported by Android Lint and Detekt, so they are mostly static analyzing tools where you're checking like classes, behavioral patterns, and Lint is more focusing on formatting. So you can think Android Lint Detekt, static code analysis, and Lint is for formatting. Detekt and Android Lint do, however, they have the capability to go and support formatting, but out of the box they don't have something concrete. Then autocorrection is something very important. If a tool finds something that is wrongly done, and in most of the cases it can go and autocorrect it. So instead of us doing the work manually, the tool can do the work for us. And Android Lint and Lint support that out of the box. Detekt does not. And then reporting, we also want to go and get some reports, ideally XML and HTML, and they're supported by all of the tools. So let's go and have a look at Android Lint. How can you go and add Android Lint to a Kotlin project? So you go and add the Android Cradle plugin, and in there they have the Lint plugin that you can go and apply. And for Android projects, Lint is automatically applied. And then running Lint is pretty straightforward. You execute a Lint task, which is added to Cradle, and then you basically get a report. It also says where the report is generated, and then in this case, the build is successful. Now let's go and take the example of the Kotlin standard library. There we use the old version, we ran Lint, and then it says, okay, hey, this is actually an old version, we can go and use a newer one. The HTML report looks like this. So you can see, usually you use this when you're developing, and then you can nicely see, okay, this is something that's not being done right. And the IntelliJ and Android Studio project also have this in your IDE. So you can also go and see those flagged in the IDE. Now for the CI, you would be using something like an XML report that can be passed by one of the tools. So TeamCD and Jenkins, they have like Lint plugins, and they usually just go take the XML output and then they can pass it, and you can say, okay, we want to be failing this build if there's a certain threshold, or we just want to go and get like a nice reporting on CI. The Lint configuration looks like this. So it's an XML file, and every rule usually has an ID. So for instance, unused resources, and then we can say, okay, this rule we want to go and ignore in a certain regular expression. We can also say that we want to go and ignore an entire rule, the Cradle dependency, and we can also say on the path that we want to go and ignore the useless leaf. Now on the Cradle side, they also have the Lint options API. And in there you can, for instance, supply the XML file for the configuration. You can also enable, disable certain rules. You can make them fatal, so they're going to be failing the build when you're building a release app. You can, each rule has like a severity, so like warning, error, fatal, and then you can also go and choose them to be higher or lower. You can say that you want to abort an error. You can also make warnings errors, which is also super useful. You can ignore warnings, and you can also check all warnings. And there's many more configuration options, but those are like the main ones that one might need to go and use. You can also extend Android Lint. It's super easy. I also gave a talk about that. I'm not going to be going into this today. And I also wrote articles about it. Now, the second tool, Detekt. So in order to go and add Detekt, we need to go and add the JCenter repository because it's hosted there, the jar file. Then we go and add a new configuration. Configuration is like API implementation compile. And then we can basically go and add a dependency. So we say a dependency, Detekt, and then we go and pass in the Maven coordinates. And the other we go, or like the reason we go and create our own configuration is so they're not ending up in our like Android app or in our jar file. So they have like a different class path. Now we can go and define our Detekt task. We generate the reports on the build reports Detekt. And then we create a Detekt task. It's basically just a Java execution. So we have a binary that we go and execute. We pass in the class path that we provided earlier with the rules. And then we also have like arguments, for instance, a config file, the input where we want to go and be scanning, and then also reports. In this case, we have an XML, HTML, and text report. And the inputs and outputs that you can see like below the Detekt configuration are just there in order to go and make it incremental. So if you are running Detekt and you're running it again, we don't need to be running it because nothing has changed. So we can also go and tell Cradle, okay, those are the inputs and outputs. Now the Detekt configuration is a YAML file. So we, for instance, can use the fail fast. Fail fast enables every rule on Detekt by default. And then rules are clustered into groups. So there's like a commons group, and then we can say undocumented public function, we might want to go and deactivate it. Now, if we're running Detekt on the console, it looks like this. So we're getting like a nice report saying what are the things that are causing errors, and then also the path. Another cool thing is they're also giving you statistics like how many lines of code do you have, what percentage of issues compared to your code you have, and also things like a technical debt value, so how much time Detekt thinks it needs to go and, or you need to go in order to go and fix all of those issues. HTML report is not that fancy here. It's just a normal report telling you the issues. XML report is the content of that is not that like important. The crucial part is that the XML report is complying to the Checkstyle syntax, so you can use the normal Checkstyle plugins that are also available on the CIs to go and take in that report and go and pass it. Now comes the interesting part: extending Detekt, because writing your own rules in Detekt is super easy. So let's say we want to go and detect internal imports, because usually you don't want to go and use classes that are from an internal package, because they're subject to change, and if you go and bump the dependency, something might go and break. So this is like our file that we're going to go and validate against. The first thing we need to do is we need to create a new module. We apply the Kotlin plugin. Oh, does it work now? No. And then again, the JSON repository in order to go and get the dependency. Detekt has its own API as a artifact that we're going to be using, and then they also provide testing functionality. First, we go and create our new class, no internal import rule. We extend from the rule class from Detekt, and we also go and get this config, the YAML file that I showed earlier. And then we basically override an issue property, and then we create our own issue. We give it the no internal import rule name. We can say in the severity it's maintainability. We give it like a message, and then also the that value. So I'm thinking, okay, it might be taking 20 minutes to go and fix this. And this is like all the rest. So those rules, they work in the visitor pattern. So you take your code, and then usually you have like a file at the top, you have classes. In those classes you have properties, functions, and then each of those you can visit. So there's like a visit file function, visit import directive for visiting all of the import statements, visit class, visit method, and then you can basically go and get your information from that. So we use the visit import directive, we go and take the path, we check if it contains internal, and if that's the case, we can just report a code smell. And that's all that needs to be done for writing your own Detekt rule. Now, the missing part is telling Detekt, okay, how can you actually go and get that rule? So they have a rule set provider that we go and extend. Then we give it an ID, Detekt custom rules, and then an instance. So the instance we overwrite, we give it a rule set with the ID Detekt custom rules, and then our implementation. So we basically instantiate our class and give it to Detekt. Detekt is using a class path loader to go and load that class. So we need to go and provide a meta-inf service file. So it needs to be on the name that is there in yellow. And then we basically provide the fully qualified name of our class. And then Detekt can go and instantiate that class, cast it down to a rule set provider, and then get all of the information that is there. Now, testing is also super easy. So we create our new test, and then we basically write our Kotlin file as a text file. And then we give two imports, ABC, a internal foo, and then we can use the lint function. And then we can basically assert that there's one finding, and the finding has the message of importing a internal foo, which is an internal import. So we not only like created our own rule in like 12 lines, we also tested it in like 10, which is super convenient. Now the only missing part is adding Detekt to your project. So most of the configuration here is the same as before, and the only difference is now with Detekt we can also say the project that we created, we're basically including that. So our custom Detekt rules module that we created earlier, where all of our files are, we just added to Detekt. And then if we go and run it, you can see here is the no internal import rule, and then it's also flagging the class. Now, Lint, the third tool. Oh God, this clicker. Also here, the prerequirements are usually the same. So we add a new configuration, Lint, we add Lint, the Maven coordinates, and then we can create the task. And the task is also the same. Again, it's on class path, we go and provide it. We can also go and specify reports, and then it's just a Java executable that we go and execute. The configuration file is the editor config that's also supported by IntelliJ and other editors. So we can go and specify the intent size, the continuation intent size, the maximal line length, and whether we want to go and insert a final new line into the files or not. Running Lint looks like this. So it's running, and then it's telling you, okay, this formatting is off. But usually formatting is something that a tool can go and fix. It's not something that we want to be fixing ourselves. So the XML report looks like this. It's just, again, can be fed into Checkstyle plugins because also they're complying to a Checkstyle semantics. And this is the crucial part, the one that's like most beneficial of Lint. It also provides with a formatting option. So we can pass the -f option. And then we basically go provide the Lint, the Kotlin files. We execute the task. And if we were to execute it on that class, the one that I've shown earlier, which is like completely out of order, we can run Lint format, and then we do a git diff, and we can see it's getting super close to what we want. The reason that there are still new lines between the class declarations is that they are actually allowed by the Kotlin style guidelines, so they're still there. But like everything else is like taken care of. The space between the parentheses, space between the colon, and also the parameter indentation is on the same level. Now, extending Lint, so we can also go and write our own rules there. For that, we're going to be using the same examples, so also flagging internal imports. And then it's basically the same ceremony. So we create our own module again. It's a Kotlin module. We have the JSON repository for getting the dependencies. Also, Lint is providing APIs for that. And then they also have their own rule class. We go and give it our name. And then they have a visit method. So instead of having like for each thing there is, so for like class, file, imports, its own method, they just go and give you an AST node. AST node is abstract syntax tree node. So everything that is in a Kotlin file can be represented as a tree. So at the top you have a file, then you may have a class. In the class you have functions, and they all extend from AST node. And then we can basically check if the element type of the node is an import directive, and from there the API is the same. So we have our KT import directive, and then there we can also go and check again whether the path contains internal or not. And if it does, we go and emit a code smell. Now, it also has a rule set provider, where we can go and say to Lint, okay, those are the rules. So we give a rule set, the ID, and also the instantiation of our class. And it's also using the same mechanism for loading our custom rules. So we also go and specify the fully qualified name of our rule set provider. We create the meta-inf file, and then also here we can unit test it pretty easily. So again, we have our Kotlin file, which is the same as a text, and then we can also go call a lint function, which is provided by the testing functionality, and then we can assert that the lint error on line 2 of our no internal import rule is flagged. And also adding Lint to our project is the same. So we say Lint project and then custom Lint rules. And then if we were to run it again, you can see here importing internal class, which is an internal import. So again, here we also have this again. Now, some more resources. You can also contribute to Lint via sourceandroid.com, the Android open source project. They also have a Lint dev group where the maintainers of Lint are also responding. So you can go and ask them some really good questions about it. Then they also have an issue tracker where you can go and create bugs or feature requests, also super responsive there. There's another video about Lint. I've also written about writing your own Lint check in a blog post. I've also open sourced a lot of my Lint rules that I use in my day-to-day development, so you can go and look at them. And another cool resource for looking at Lint rules are the Lint rules that are shipped by Android Studio. So all of them are also open source, and you can go and find them here. Now, Detekt resources, it's open source on GitHub. You can also go and contribute there. What's also super nice is there's a Kotlin Lang Slack channel where everyone can go and join, and you can find everything about Kotlin there. And Detekt also has its own Slack channel there. And I've also written about writing your first Detekt rule on Medium. Lint does not have a Slack channel, as far as I know, in that Slack community for Kotlin, but it's also open source where you can go and contribute. And then also, I've written an article about that. And that was basically everything that I wanted to go and tell you. Those are the resources, and everything that I've shown you here, all of the code samples, all of the Cradle configurations, the custom rules, they are all in the GitHub project that are linked here, the Kotlin on code quality tools.
Okay, do we have any questions?
There are 2 max that I can go and give away.
No. Maybe I am not an Android developer, but you said there is a Kotlin, Lint, Android Lint. Is it possible to mixture them? Let's say some part of application could be tested by Android Lint and some of them by the KT Lint?
Yeah, so you can go and add all of those tools to the same project. You can go and add them to Java-only project. You can add them to Kotlin-only project. You can also go and add them to Android projects. So you have like all of the flexibility that you want.
Okay, thank you.
I would like to ask if you have experience using Sonar Cloud, because recently they start to support Kotlin analytics.
Yeah, it's SonarQube.
SonarQube Cloud, yeah.
SonarQube Cloud, as far as I know, they're actually using Detekt for the analyzing of Kotlin code. I don't know whether they are actually also using KT-Lint, but I know that Detekt worked on getting SonarQube to support it. But in the end, SonarQube is basically just like a wrapper. So all they're doing is using other tools. And I'm pretty sure they could also be supporting KT-Lint, and I'm sure they're using Android Lint too.
Just a comment on that. SonarQube, in the latest stable release, supports Detekt, and is the only Kotlin static code analyzer that it supports. And it's not officially supported, but you can put it in.
Okay, cool, thank you.
Okay, do we have more questions? So I think this is it. So thank you, Nick.
Okay, thank you.